All right, guys, welcome back to Within Tolerance. This is episode 67, and we have a guest on. We have Matthias from Hermle, and he is let's see, you're
I'm
we're
the
an
applications
engineer.
manager.
Okay. And so, how long have you been working for the company?
Been with Hermle about 6.5 years now.
Okay. And then I guess for everyone listening, I'm and myself included and Dylan, let's just start off. How did you get into manufacturing? Go as far back as you want. Were you a kid that just liked to make things? Were you a tinkerer? Did you like to just build things in your garage? To kind of present day, how'd you get the job and what do you kind of do now?
Yeah, sure. So, I mean, for me, I've always liked to work with my hands. That was kind of my big thing. I don't know how many calculators I tore apart when I was a kid and other stuff that my parents, they couldn't believe, well, why would he tear this apart? But it was kind of the interesting thing is how does this work? So, it did take a little bit of a turn there. So after I got done with high school, um, well, we moved to the States. So I finished up high school here in the States, and then what my path really was going to be is I was going to go join the service, and I got an Army ROTC scholarship to go to Marquette and for mechanical engineering, and I did that for 2 years. But pretty much after that second year, I realized that schooling is just not my thing, and was kind of making a decision: do I want to keep paying for a college degree that I'm not really that into, and it's not working for me? And so there was a point where I just said, you know what, I'm going to stop before anything else happens, because the Army was like, well, if you don't bring your grades up, you're going to pay for it, and you get two choices. You can either go then start enlisting, and then we can work something out, or you keep paying for it. And I made the choice to just completely stop at that point. And during that time, though, already I worked a lot in the machine shop there, and I got into contact with the gentleman that I worked for or ended up working for. So the summer before there, I already did some work for him, and then once I left Marquette, I worked for him full time. So what they did is they made sewage aeration products. It's a pretty unique industry, but essentially you can look at it as a 20-foot PVC pipe. They put these platters on there with the rubber membranes that have holes in them, and then they put those in the bottom of sewer tanks, and they pump air through them, and the air then lets the bacteria, grow and do their job. So the assembly of these things, and I mean, we're talking about hundreds and hundreds of pipes for one of these tanks. He wanted to automate, so essentially, with the engineer there, me there, we kind of put together this machine that had a robot on it that took these cups, placed them on there, ultrasonically welded them to it, and so on. Um, Kind of, it was pretty dependent on right around when the last crisis was, and the municipality still had money, but that was also on that kind of wave going down. So at the end there, when we were really done with the project, work was slowing down, and for me, it was time to go explore other avenues. So I started working at a company here at the cylindrical grinding. I pretty much went in there. I said to the guy, "Hey, you know what? You don't have to pay me a lot. I just really want to learn how to grind." So then I did that for a while still working at the other company, but really started cylindrical grinding, surface grinding, a whole bunch of things. And then going on, essentially, I said, well, it's time that I get some credentials. And after that, I was fortunate enough to start or get an apprenticeship at a company here in New Berlin, Stanek Tool, as a toolmaker apprentice. And then I did a 4 year apprenticeship for a toolmaker and worked there those 4 years. And then after that, again, kind of, that economic thing is going on, and I really didn't want to be out of a job. So I started looking around, and that's where I saw that Hermle was hiring, and me having, you know, me knowing what the company was about from Germany already. I was like, hey, I'm gonna give these guys a call, and then kind of went from there.
Awesome. So what's the path through Hermle? Like what did you start as, and then how did you work your way up to applications manager?
So really, I started as a junior application engineer. Um, you start out doing trainings of the control. So for Hermle, we integrate Heidenhain and Siemens controls, and I've come from pretty much a Fanuc background. I mean, not all Fanuc controls, but it's like kind of that standard, if you will. So I didn't really know much about that. So the first step was really, getting introduced to Haydn and understanding the machine and doing that. And then you kind of work your way through that, and then when you get a good understanding enough, then you start interacting with customers. So I did a significant amount of time on the hotline. So the way the company's set up is we have our sales, we have our financial, we have a service department, and we have the applications department. And both the service and the sales, or the service and the applications department, have what we call a hotline. So that is where somebody can send in an email, give us a call in order to get anything resolved. And working that hotline then kind of, it really gets you digging into problems, and then you having to understand those problems really helps you out understanding the machine that much more, right? Because you can go to a training class, and I did go to Germany for training, but it's using the machine, doing this, doing that. It's really when you have to start kind of going on your own um, to investigate an issue is where you really kind of get those fundamentals down and that understanding down of what's really going on in the background. After that, I started doing test cuts, started programming demos, and really what happened somewhere along the line, we had some changes. People came, people left, people changed around in positions, and the position for application manager was open at that point. And Mr. Schnitzer, he approached me and said, "Hey, are you interested in doing this?" So at first we did it kind of on call it a junior level, where he was still in charge of the applications department. But then, after about half a year, it kind of became finalized that I would now run the department.
Awesome. Well, we really appreciate you coming on. It sounds like you're definitely the right person for this podcast.
Yeah. So I guess a question I have for you is, so day to day, what are you doing currently?
Oh boy, um, quite a bit of things. I mean, so one of the nice things about the job is because it's not just you're not just doing one thing. I mean, it's very email intensive on my end, but one of the big things is I'm not going to lose touch with the machine. So it's I might not be on the machine every day, but then there's certain projects that I'll say, you know what, I'm going to do this, and then it's just a matter of you're working through these projects. The biggest thing for me right now is really interacting or getting stuff planned out, whether that's sending an AE to a customer, whether it's new projects that are coming on, taking a look at those projects, and then seeing, well, what do we need to do to get this into the pipeline to get it worked on. So if we were to take a look, for example, a new customer approaches us and says, "Hey, this is kind of what I'm trying to do. This is my thing, what I'm thinking of. What do you guys think?" So then that all happens on the sales level. And then usually what happens at that point is the sales manager is going to come either to myself or to my boss, Mr. Schnitzer. And, he'll say, "Hey, I got this project here. We would like to get a feasibility study." So then the next thing that happens is it gets to the applications department, and at that point, I'll take a look at it and say, "Okay, is this something? Is this not something? Who should work on it? And what direction do you really want this to go?" And then at that point, I see, do we have enough information to get started on it? Do I need to go back to the sales manager and say, "Hey, we need this and this additional information to make any determination"? And then once you have that kind of foundation laid out, then I usually hand that off to one of my colleagues that will then kind of take the project over and kind of work it through until the end of it. So that's pretty much my day to day. Is a lot of emails, but I still try to be out there on the shop floor too and run machines, because for me to go to a customer, and I do that quite a bit too, is I just go to customers, I demo machines, being able to talk intelligently about the product, you really got to have some hands on.
Definitely. So, kind of stepping back, then I guess, why do or like who is Hermle's major customers? Why do people come to Hermle versus other machine tools? What do you guys specialize in? What do you guys what's your value proposition to your customers?
Well, I guess if you wanted to just define it, it's going to be high-end 5-axis milling machines. So we do build some 3-axis machines. There's a couple out on the market right now, but primarily we build 5-axis milling machines. And it's a pretty broad variety. So it's not just it's not just aerospace. Even though if you look at our machine design, rotational symmetrical components, it's like there's nothing nicer than the setup that we have with the ANC trunnion for that. It's just ideal for it. But we also have a lot of customers in the die and mold industry, medical industry. So it's a pretty broad range of customers that we cater to. I think the biggest thing is if you're looking for a really reliable product, then we can have an answer for you.
Okay, that's great. So we've got quite a few customer questions. We'll kind of bounce around. Let's see. Oh, so Obsidian Tools asks, like, what are the differences between a gear and a direct-driven C-axis regarding to longevity, precision, speed, and stiffness, and is it worth the upgrade? So, do you guys offer both gear and direct-driven?
Yes, correct. So there's two lines of machines. We have the performance line, and then we have a high performance line. On the performance line, we only offer gear-driven or worm-driven C-axes. Then on the high performance line, you can option to have a torque motor in the C-axis. It's kind of an interesting topic, and when looked at this, yes, it is a mechanical system, and yes, there is going to be wear. It's just that's kind of the nature of a mechanical system. But that being said, I wouldn't say it's less accurate, less good, or anything. I would say it's the biggest difference that you're going to see is pretty much speed. And in regards to the longevity of it, there's machines out there that are worm driven, with 15 plus years, where you're not necessarily replacing it, you're just adjusting it. So if you look at the whole worm gear system, there's a spacer in there that you can grind down. So should there be any backlash, if you will, then you can grind in that spacer. But that being said, is on all of our axes, there are scales. So the machine always knows where it's at and it's striving to that. So it's not necessarily less accurate than that. The best thing to always look at is, really what do your parts demand? Are you doing a lot of C-axis movement where you're constantly turning the C-axis? That's when I would say, we definitely should look at a torque motor. Are you using are you using a lot of collision avoidance? So especially in the die and mold industry, right? You say, okay, machine down from the top, and then as soon as your holder starts getting closer to 2 millimeters, start tilting away. So this collision avoidance moves usually require that C-axis to turn really quickly, and then being able to have that dynamic motion is really where you then say again, I want a torque motor because it is more dynamic than a worm-driven system. But if you have a lot of let's call them geometrical parts where where it's essentially a cube or an L or whatnot, and it has a whole bunch of holes at different angles, that's really you don't necessarily need one. That being said, you still have the capability with the worm drive to do full simultaneous moves. I mean, the bull was done on a machine that had a worm drive, and pretty much all of the finishing paths were all simultaneous paths.
Okay. So we had another question about turning on the mills. Is that an option that is only available with one or the other, or is that something that you can do with either a gear or a direct-driven
Correct.
C-axis?
So that is only going to be available on the machines that have a torque motor. So only on the high performance line, and then we only offer it on the C42, the C52, and the C62.
Okay. So what I guess what kind of customers were you seeing that are buying that, and like why did Hermle start offering turning on such a larger 5-axis? I mean, I feel like that's kind of a niche product.
Well, I mean, there is quite a bit of customers that aren't in aerospace, but I'm going to definitely say most of the people in aerospace, again, those rotational symmetrical components, um, that's really where those tools kind of shine. It's because you can have your part, it's one setup, or even have to flip it around for the other side, and it's then two setups rather than going from a turning machine or a VTL to a mill and then back and forth. So it's like do everything on there, and for anything really in a jet engine, there, if you look at it, where you're mounting the blades and whatnot, all those components are definite candidates for those types of machines.
Gotcha. So you're talking like blisks and things like that are beneficial.
hmm Um,
Okay.
So that's kind of the way we look at it as rotational symmetrical components. So if you think about it, an impeller, blisk, they were all essentially revolved items, and then you cut out the vanes of it, right? Or if it's a disc that holds the actual fan blades, where you have the fir tree profile in there to hold those, those are all then components that you would see on a mill turn machine.
Totally. So how do you guys hold the lathe tools? Is it just servo locked in the spindle, or are there actually dogs that the lathe tools orient to, or how does that work? How do you guys hold that
So
kind of rigidity?
it depends on the model, or I should say, depends on the spindle more or less. With the HSK 63 interface, it is essentially clamped hydraulically. You can almost look at it as like a collet. It just clamps down on the sides and it holds that in. So the spindle will index to whatever degree the tool needs to sit at, and then it will lock up the system. On the larger spindles, there's a tooth coupling inside, and that once that engages, it gives you the kind of the fixed alignment, if you will.
And talking about spindles, do you guys just have machines that use HSK in different sizes, or do you have any other types of spindles?
So currently we would offer HSK type and as well as SK. So
Okay,
HSK 63, HSK 100, and then the SK 40,
Okay, cool.
which SK is similar to a cat. It usually on the cat they don't have the notch. On the SK holders, there's a notch for essentially the loading direction.
gotcha. And then we had a question from Adam, the machinist, and he talked about what are some important machine and accessory details to consider when shopping for 5-axis machines.
Yeah.
And I'm assuming your answer would be, part dependent or project dependent.
Yes, definitely. I mean, um, where do you start? So there's small machines, there's large machines. You can go all the way to the high end. There's also machines on the lower end. What are you trying to do, and what are you looking at?
So I guess a question that I have, just
Uh,
coming up in conversation would be, so let's say I want to start a job shop doing really high-end 5-axis parts, one-offs and whatnot. Um, do you guys have customers that buy machines for that purpose?
yeah. Um, no, I mean, there's definitely some, places that are opening up shops and they're like, I need a machine and I really want a 5-axis machine, and that's what they're going with. So, kind of again to go back to that question, one of the things I would say first and foremost is what type of support can you expect? Um, what I see a lot of times is people that have no 5-axis in their shops, which is probably the bulk of our customers. They have 3-axis, they have 4-axis horizontal machines, and then there's this next step to a full 5-axis machine. And it's kind of this, I don't want to say new territory, because it's essentially it's still the same things you're doing, you're just adding another axis, but there's a couple things that go with it. And for somebody that hasn't really dived into it, it can be a thing. So what type of support can you expect? Can you call up a guy and say, hey, I'm looking at all these vices, and what should I really be looking at? And, having somebody to be able to talk that through, I think that's one of the big key things, is because you always have that kind of shoulder to lean on. When you run up to a stop, and it's not just like, well, I'm hanging in the air now, I got to figure it out myself. The other thing is going back to those parts. So you know consider your parts and consider what kinematic makes sense, and then what travels make sense. Um, a lot of times what we'll see is, it's a large part, and let's just take one of our machines, the C42, for example, that has 800 millimeters in X. So then, the part might be 850 millimeters. And then some people say, well, I can still machine this, I can still machine this. And well, what happens when you start tilting it? How far is it projecting out from the table when it's tilted at 90 degrees? Do I still then have enough travel to the front of the machine in the y-axis? So those are all things that you kind of want to play through, because what you don't want to do is you don't want to have, yep, I got my machine, now I got my part on there, now I'm going to start machining, but all in a sudden you load your program and you're going to start running into all these travel limit errors. So that's definitely something that you want to consider: the parts, your fixtures, and then what travels do I really need in order to accommodate that. Another important thing is, I would say, is the spindle to table clearance. So a good rule of thumb is, essentially for us, our C slide going up and down from our traveling gantry, modified gantry, there's a distance from the back of the sheet metal to the center line of the spindle. So as soon as I move my part, 150 millimeters, whatever it is for the model, then I can say I can tilt up my table to 90 degrees and reach all the way around it without having any collision considerations. So I would say that spindle to table clearance is a big one, because when you got a large machine and you want to work smaller parts too, is you need to be able to reach in there. You don't want to have a tool that's 300-400 millimeters long. Then again, the kinematic arrangement, I think, is pretty key too. Some kinematics, they have their challenges, I would say. Others are easier to understand. I would say for us, ours is pretty easy to understand. I mean, we have our X, Y, and Z in the top portion of the machine, and then our A and C in the bottom portion of the machine. Once you're starting to look at, for example, nutating systems, okay, now I'm turning this part. Well, what is that effect going to be? For me, I can say, all right, turn the A axis 90 degrees. Now I know I'm on the back or front side of the part. So those are all things to kind of consider. And then the biggest thing is geometry. So pretty much everything that builds up to a good machine, I would say, is the geometry of the machine. If you have a solid geometry, then you're all the things that happen afterwards are going to be so much easier. And with the geometry, what I mean is more like, perpendicularity of all the planes, straightnesses of the travels, all those things then later figure on and will reflect on your part.
And if I remember right, you guys do things like build the 0-point systems and things like that into your table too, on customer requests. Is that right?
Correct. So pretty much, it's you can configure the machine how you would like it. I mean, yeah, we have standard machines, we have standard tables. That's what we see most of the time. But especially in the, when it gets to automation, people are saying, hey, I'm using this in this system. For example, Lang has a 0-point clamping system. We can integrate that directly into the table, or maybe it's an Aroa system or whatnot. This can all be integrated into the table directly, and then handled that way.
Which will save you on Z travel at least a little bit.
Yes. Even though there's you want to be able to build up a little bit or go down a little bit, so it's not necessarily that you always have to consider that C travel, unless of course you have really tall parts. So usually there's a generous amount of travel that you end up having.
Okay, yeah, that makes sense because you want the part far enough away from the bed that you can still get to it at different angles. That makes total sense.
Yeah, so I mean, a lot of people will say, "Well, I can't reach the table with the spindle." It really depends on the whole configuration, what type of table you have, what type of machine model you have. But on none of the machines, the spindle will not touch the table. So usually there's, I want to say, just off the top of my head, about a 200 to 150 millimeter clearance for that, if not more. It really depends on the model and the table configuration. But you really want that distance where, let's call it a dead space, where you can't really reach anything. Even if you have a really stubby holder, you probably wouldn't even reach the table. But you want that dead space because most clamping systems, once you start building up, they'll get you to that center point or that center line of the A-axis, and that's really where you want your part to sit. So one of the ways to look at that is that the further away from a center line of any of the rotary axes your part lies, the more you could argue is your error, right? Because if there's any error in the whole system, the further out that or the lot larger that triangle gets, right, the more your error is going to be. So if you can kind of position your part right there in that, let's call it a sweet spot, then it's really ideal.
Okay, yeah, that makes sense. So that actually kind of jumps into D-Man 151 Racing's question. He wanted to know, how does Hermle and how does Heidenhain handle dynamic fixture offsets versus tilted work planes? What do you guys prefer when you're programming or advising programming on your machines? How do your machines handle that kind of thing?
Sure. So pretty much for both the Heidenhain and Siemens control, um, they call it different things, but essentially they're the same. So I'm going to go with Heidenhain here. If you look at 3+2 machining or tilted work plane, that would be a plane spatial function. And really what it does is essentially it turns the coordinate system about which axis you're defining. So if you're using plane spatial with an SPA or SPA, SPB, or an SPZ definition, then you're essentially turning it about the X, turning it about the Y, and then turning it about the C axis. And depending on how your numbers go, that's what it then turns that coordinate system out. You can then also tell the machine, okay, you turned it numerically, but now I want you to calculate what the resulting axis angles are and position to those axis angles. And then your part now will be presented to the spindle again on that plane. So anytime you're working with 3+2, you really want to use a static or a tilted work plane type of command. For true simultaneous is when you then do a dynamic work offset. And the best way to describe that is essentially if you took a coordinate system, so if you took your X, Y, and Z, so I believe it's called the tetrahedron, right?
Mm-hmm.
And flopped it on the table. As soon as you put it on the table now, you turn on function TCPM. So that's what it's called on the Heidenhain side. Once you turn that on, and let's say I turn my table 90 degrees, I'm also turning that coordinate system 90 degrees. Versus as when I'm using plane spatial, the C axis will always point up in line with the spindle axis. Whereas now with the dynamic, if I start now tilting my A axis, that might be pointing towards me, that might be pointing away from me. And essentially the coordinate system is moving with the table. So as soon as your C moves, it moves along with it. And once your A moves, the whole thing becomes comes to an angle. So there is no which one is better, which one is worse. It's essentially what are you trying to do. So if you're doing a 3+2 operation, you really want to use a tilted work plane function. And when you're doing simultaneous work, you really need to be using a dynamic function, such as function TCPM. On the older controls, it was M128. On the Siemens control, it's going to be Traore. So there's no this is the right one or this is the wrong one, or you want to use that, even though some people use the dynamic all the time. Um, you can do that as well. It's just when you use plane spatial or cycle 800, having that coordinate system then kind of back in line with the machine, just on a different plane, makes it a lot easier when you're standing in front of the machine and saying, well, why is it drilling this hole now here and here? You kind of can relate to it as a person again.
Gotcha. So the machine doesn't really care what you're using; it'll still be just as
No,
accurate. But as far
yeah,
as human friendly, it makes more sense to do tilted work plane when you're doing 3+2.
correct. And I mean, you can give a 3+2 definition. So if I use plane spatial and I give it a certain or SPA, SPB, and SPC combination, I can tilt that, or I can turn that coordinate system that X plus now looks in the X minus or looks in the Y, but the spindle axis will always be in line with the Z of my coordinate system. But again, once you kind of understand that, well, why would I want to turn my coordinate system? For me, it's a lot easier when I'm, let's just say I'm working on a cube and I need to drill a hole in the back. So on the back face, right, I want to then my machine to tilt up my part and drill that hole at a certain spot. And when I see, all right, I'm positioned at plus 50 millimeters, 100 and something over, does that make sense? I can take a look at my print and say, yep, that makes sense, and then drill the hole. Versus if I were to do that in a dynamic offset, that number might be something completely different. Um, so it makes it relatable.
Gotcha. Yeah, that totally makes sense. And then kind of to dovetail off the end of that, we didn't have it written down, but what do you prefer personally? Do you prefer Heidenhain or Siemens?
Oh boy, um, I get that asked a lot. The best way to answer that though is really, what are you trying to do? So the Siemens is an open platform. You can pretty much do whatever you put your mind to. Versus the Heidenhain is a closed platform, but it makes a lot of difficult things very easy. Versus the Siemens, it makes a lot of difficult things, or a lot of easy things very difficult. A good example for that is on a Heidenhain, I can go out in the shop right now. I can call in the touch probe. I can pick the cycle for probing a circle. And then within that cycle, I can say, you know what, on the screen, I want to see the result of the measurement. Now, there's ways to do that on a Siemens too, but there's a couple more steps involved. And then if you really wanted to dig into it, then you could say, you know what, I'm just going to write my own cycle because I don't like any of these cycles anyway, and I got all these functions available, and then you can do your own thing. But it's kind of what do you want to do? So if you like controlling things, go with the Siemens. If you just want to get out there and get something done with the available tools already at your fingertips, then I would probably say go with the Heidenhain. Me personally, if I had a garage shop, probably a Heidenhain control. If I was doing something that needed a lot of monitoring, a lot of evaluation, a lot of work in the background, then I would probably say, hey, I'm going to go with the Siemens control.
So do you end up selling more Siemens controls with higher level automation systems?
Not necessarily. So I think the biggest, the most machines we sell are going to be with the Heidenhain control, even though you can definitely say that the Siemens has caught up in the past couple of years. So if you look at some of the previous, it's Siemens 840, but then there's different software revisions. And really with software revision 4.5, 4.7, now 4.8, they have really done a lot of things to make it easy to stand in front of the machine and say, hey, I just want to probe this. Versus in the past, you had to know this cycle, and then you had to know the variable that it saved it in the background, and then you had to kind of know, well, how do I call this variable up now, and how do I write something that will print it somewhere, whether that's on a screen or saves it in a file. And that's why I think in the last couple of years, definitely Siemens has also caught up in those job shop environments where you want to be able to do those things rather easy.
So going back to talking about your favorite control, I'm curious, what's your favorite machine to run? Like maybe back when you were, working at some of these other companies doing machine work, besides the Hermle.
Um, so the very first machine I ran was a Haas. It was a tool room one, I think is what it was called. After that, I worked on a Metsura with the Yaskawa control at another company. Then we started adding the Fanuc controls, the OSPs, there was just a plethora of controls. And that's kind of why I'm saying all those Fanuc style controls. I think Fanuc definitely has its place in the industry, and you can't ignore that, its popularity. But I think I would find myself really challenged going backwards now. Um, if you look at a Heidenhain control, we could open up a control right now. You and me could stand there, and I could say, "What is this cycle doing?" And if you looked at the screen, you're going to see cycle 200, universal drilling, and then there's going to be Q parameters below it. And after every Q parameter, there's going to be a comment. So without even knowing anything about the control, if you can just read that text, you would be able to then tell me, well, this is a drilling cycle. And then if we were to go into this cycle and say, hey, I want to drill 20 millimeters deep, you could look through and say, oh, drilling depth. All right, this is where I need to enter my 20 millimeters. Versus if you look at on other controls, you're looking at, well, G81, then you got your XYZ, then you got your R, then you got, well, what is any of those things? And then on some controls, it's W for the dwell, on some it's F, and it makes it pretty difficult to know unless you know, right? So that's why I'm saying it will be really hard for me to go back and if I went back to a shop, I definitely would want to run a Heidenhain control or a Siemens for that matter. Probably more so a Heidenhain. I don't know. I'm always a little bit. One day it's this one day it's that one, but both of the controls are pretty much at that level where you can actually understand what you got in front of you, and it's user friendly. This is what we see a lot of the times too. Is you got people coming from shops that have run Fanuc their entire career, and they want to see G1, they want to see G0. Well, Heidenhain doesn't look at it as G0. If I want to move the machine from point A to point B, it's going to start with an L. So L for linear move. And then if I start that line and I say, yep, I want to have an X coordinate, I put in my X, then I error over to the next, and it already fills in Y. It's very intuitive. So most of the people that are open to just giving it a try will come back months later and say, hey, I don't ever want to run anything else again because it is just that intuitive. And, when you get into the probing things, all this stuff is already there. So you just essentially have to grab it and then give it the values that you want in your process. And then even if you want to dig deeper, so yes, the Heidenhain is a closed platform, but it also has variables available to you, and it has functions. What do you want to do with those variables? So if I say, well, I'm going to measure this hole, then I can say, okay, well, the cycle writes it in Q150, Q151, Q152. Now I can say, well, if Q150 is greater than, let's just say 5 millimeters, then jump to this part in the program. If it's less than, I'll jump to this part in the program. So it's even gets to the point where you don't necessarily have to be a PLC programmer or understand C or any of harder programming languages. You can simply implement these things and get some process monitoring going rather quickly. It is not as open as the Siemens control, but it gives you kind of those basic tools.
Makes sense. So, kind of going off of some of what you said, one of Jake's questions was, when Gunther finally gives you your own Hermle, what model would you choose and why?
Yes. So it's definitely going to be the C650.
So the 3-digit ones are your performance line?
No, so to
or
give you a little bit of an
performance?
overview, um, we have a C12, C22, C32, C42, C52, and a C62. Those are all high performance machine. And then the C250, C400, and C650 are the performance line. So yeah, anything with the 3-digit is going to um, be a performance line machine.
Okay,
But for
so
me, it would
why the
definitely be
650?
I would just say it's a broad range of applications. So the way I look at it is you can always make a small part on a large machine, but you can't make a large part on a small machine. And I just, I really kind of fell in love with those travels, and it's big, but it's still not that next step up to like a C52 or C62. So you can do a lot of work in it. It's just, I really like the machine. Overall, working in front of it was great, and just having that meter travel. So you have 1,050 millimeters in X travel. I just think is ideal.
Yeah, that's
It
giant.
just allows for a lot of parts, and then I mean you can put a 1,500 kilograms on the table. So it's like you can throw a lot at the machine. And then even if if I were to then say, okay, I don't have any large work, and then you start getting into the small work, well, at that point it's just, well, put a riser on the table and get that spindle to table or spindle to table clearance, and then you can also work on small parts. So it's kind of a nice medium for me, and that's why I would pick that. And
Yeah.
if I had every choice, and somebody could make the argument, well, why didn't you go with the high performance line? Um, you don't always need a high performance line, and with that also comes a lot of other things. So when you're starting to get into high performance, well, um, do I really need those dynamics? Do I really want it to even go that fast? If you stand in front of our C22 and that thing makes a move, you're going to blink, it's already there. Versus on a larger machine, I don't know, it's just that feel, I guess, of it. That's why I would go with that.
Makes sense. So actually, I was looking at the C650 right now on your website, and I realized we don't have any questions, but I'd love to talk a little bit about your collision protection on your spindles. That's one
Hmm.
of the tabs on that, and I completely forgot to ask anything about that. But it seems like a very specific thing to Hermle.
Hmm.
So
Yeah,
what
definitely.
does it do, and how does it work, and what makes it special? I guess.
Well, the best thing is if you don't ever use it. Um, but if you do end up using it, it's usually not a big deal. So I think that's one of the things that a lot of customers appreciate, because if you have a collision, then usually that's a pretty pricey endeavor. Um, so what happens is, if you have a spindle, and not all of our spindles have this, but if you have the spindle, and this is going to be like, say, the standard spindle, um, then essentially there is a system of crash cushions. So you can imagine it almost like a tube. And once you act, or once the collision happens, essentially you're going to crush these sleeves. And as soon as the sleeves get crushed, there is a ring that then gets actuated, and it pushes on an emergency stop. And at that point, those sleeves are then compressed. The system is triggered. Um, and most of the time, you're going to end up giving us a call and saying, "Hey, I had a collision. Um, it's giving me the error message, exchange spindle head, and then you need to exchange it." The process is pretty straightforward. So you're going to end up taking the sheet metal cover off the C-axis slide. You're going to unbolt the head of the machine. You're going to drop it out of the machine. So essentially, you're just going to park it on the table on a fixture. You're going to wheel up your C-axis, and then you have one or two options. You can either use an exchange head, or you could actually replace the crush cushions, because most of the time, the crush cushions absorb all the forces of the collision. And then you replace those crush cushions, you torque them all back down, and then you reinstall them in the system. you perform a geometry check, and off you go. So if you look at it that way, I'm not 100% sure what the price is, but I, you know, those crush sleeves, they're not really that expensive. I want to say a couple $100 will get you the set, and then the technician's time and whatnot, and then you're up and running usually within a day. If you exchange the spindle head, you get a core charge for the one that you have. You have a new spindle head in there, and then you're also up and running with a relatively lower cost, and then obviously the time. Like I said, usually within a day, you're back up and running. Where I would say a lot of the time then is taken in doing the geometry checks again.
That's pretty amazing. I mean, that from what you said, it sounds like it's 10% the cost of a new spindle, if not less. Because I know those spindles are not cheap. So
Yeah, I was curious. Do you know ballpark how much a new spindle would cost?
Um, Not off the top of my head. I want to say it's in the 15 something, but don't quote me on that. So
okay.
that's if you're doing a replacement.
Right.
But don't quote me on it. But a lot of the times, and a lot of customers even do this themselves. So again, we offer service training as well, and you can get the training to where we get you to the point where you can exchange these parts yourself. And we have a lot of customers, they'll change these crush cushions themselves, they'll change the spindle themselves, and depending on I don't want to say how good you are at it, because you shouldn't want that practice, but you can have that thing back up and going again, probably the same day.
That's amazing. That is really definitely a special thing about your guys' machines.
I mean, what you got to say is it doesn't protect you from all crashes. So what they tried to do is they tried to find, what is the force that the bearings allow, and then just right below that have that of the crush cushion, so you can get the maximum out of the bearings. But then it's that fine line that you're trying to walk of what's maximum allowable and what's still healthy for the bearings. If you look at it then further a little bit is, if you have a radial collision, which aren't that common, usually your collisions happen in a C direction. In a C direction, that's really where that force gets absorbed, even though it can also absorb it in the X and Y plane, but not as easily as in the C plane. And most of your collisions are going to happen in the C direction, whether that's because you have your work offset wrong or your tool length's wrong. Usually you come over your part and then you wrap it down, and that's where we see most of the collisions happening.
And I guess
Totally.
another question we had from Split 141 was, what is the worst crash you've ever seen?
Or been a part of. Yeah.
Yeah.
Yeah. I mean, I've seen some pretty interesting pictures. I've seen some HSK interfaces completely sheared off.
Whoa.
Some lasers that got completely destroyed and all of that. The one that I've seen myself wasn't with Hermle. It was in my previous job. Somebody put, I think it was like a 40 millimeter drill, one of the indexable drills into a part. He walked away. The insert popped, and he essentially welded that drill into the steel, and then it pulled out the whole retention knob assembly. And yeah, that was kind of the worst thing I've seen. I mean, kind of when the spindle spills its guts on the table.
Wow.
Then I mean, also got to see some holes drilled into table. You get to see a lot of interesting things, but I want to see the worst one is probably where that drill melted into the steel and pulled out that retention assembly.
Wow. That's scary stuff for sure.
I mean, I've had a couple of oopsies myself. Pretty much, I think the one that was the most devastating was to me was right at the beginning of my career, where I was building that machine, and I went to my boss. I said, we need to order this end mill. The end mill costs $300, and he's like, well, do we really need it? And I'm like, yeah, I really need that length. and then get it all set up, and then I think it was a 3/4 end mill, and I had my path going, and all of a sudden, I had a wrong number programmed, and then thing just snapped off, and I was just devastated because I had to go back to him for a $300 end mill. I mean, today I look at it, it's like, well, it was just an animal, wasn't that big of a deal. But I think back then, and just how new I was to everything, that was kind of one of the most devastating things.
Yeah, that sounds
Today,
like
one of my guys comes up to me and says, "Hey, I just broke off that end mill." I'm like, "Okay, well, did it damage the machine?" And then as soon as he says no, and I'm like, "Okay, just grab another one."
You know the pain now.
Yeah, but I think especially for people that are starting out, and it's like, well, $300 for an end mill, and then you've used it 10 seconds, and all of a sudden you got two pieces laying in front of you. That's pretty. But I think it's also part of the growing experience. So I think in your career, you have to have those experiences because they teach you something, I think.
definitely. Yeah, we've talked at length over the year we've been podcasting about how machining constantly humbles you, and every time you think you're hot stuff, it comes back to bite you, and it's definitely those kind of experiences where you learn the most.
No, definitely.
So Jake had a few questions, and let's kind of maybe go down the path of programming a little bit. So you are a heavy power mill user, is that correct?
That is correct.
So what's your most favorite and your least favorite power mill feature or function or anything like that?
My favorite is definitely going to be being able to toolpath edit. So that's a pretty broad range in Power Mill, but pretty much I can take let's just take a line path, and I say, well, it's a little too long. I don't want it to go that long, and then I just say, well, trim it at this point and throw the rest away. You can, a lot of times what happens is, let's just say, I got a mouse in front of me right now, and I want to throw a 5-axis path at it and just calculate it out. And generally speaking, it will be a nice tool path, but there's going to be some areas where, there might be some weird movements on the undercuts or on this and this part. Now, you can spend a lot of time trying to, break up surfaces. You can spend a lot of time trying to feed it exactly the right parameters, feed it exactly the right surfaces and whatnot in order to get that perfect tool path. Or you can just say, what, I'm going to let it calculate the whole thing, and whatever I don't like, I'm going to throw out. Going back and just saying, hey, I have this feed rate. It didn't work. Well, I'm just going to tell the system now to use a different feed rate. I don't have to recalculate the tool path. I just go into my edit menu. I say, well, I want to edit this and this parameter of it, and I edit that. So that is the tool path editing capability is definitely my favorite part of Power Mill.
Okay, and then what about your least favorite, or what do you find difficult to program or difficult to use in Power Mill?
It's not so much the programming part of it. It's so when you do 5-axis tool paths, or I should say, when you're using ball end mills, you can either post to the tip or you can post to the center line. And all my 5-axis tool paths that I run a ball end mill on, I always post to center line. The reason for that is when you have certain moves, and if you were to look at the tool path on, for example, Simcoe, if you post to the tip, it might look like a ball of yarn. It's just a jumbled mess. And when you look at it on the center line posted path, it might be a nice straight line. And I wish that Power Mill could show me that on the screen, but it can only show you tip moves. It cannot show you center tool paths. It can post to the center, but it doesn't show you that. And the way I've talked to an Autodesk guy about this, and he says, in the background you have both calculated tool paths, but you can't see the center line one. It's just inherent in the numbers in the background in your cut file, but it's not something that you can see on the screen. And one of the things that I'm a big believer in is look at your tool path, look at the points of those tool path, and if that stuff looks good, you're going to have a good looking part most of the time. But if you already see there's you got these zigzaggy lines on your tool path, then I would say, what are you going to expect to reflect on your part? So a lot of times what we have is we have customers calling in and they're like, well, I got all this, I got these dots on my part and I don't understand where it comes from, or my machine's kind of has like a jerky move. So we ask that you then send us the program and we'll take a look at that program. And a lot of times what we can do is you can just zoom in that area and you'll see these points and they'll make little zigzag lines. And it's directly reflected on what your machine's going to do. It's kind of that mentality of garbage in, garbage out.
Definitely.
So that's why I want to see exactly the path that I'm going to output as a NC code, and I want to see those points. And not being able to see the center line of the tool kind of is a big bummer for me.
Yeah, that definitely sounds like it could be a little frustrating. So speaking of tool pathing and all of that, you were the one who programmed the bull from IMTS 2018, and so Jake asked, what type of toolpath did you use on the bull testicles? But let's kind of step back before you answer that and just talk about the whole process of making the bull. Where'd you start? Where'd you, what programs did you have to use? What kind of challenges did you face?
Sure. So I'll step back just a little bit further. So usually what happens when we look at trade shows, we'll look at, well, what do we want to show at these trade shows? And we kind of come up with this might be cool, this might be cool, this might be cool, and then we kind of finalize on something. So we said, what, a bull will be cool because what does a bull symbolize? It symbolizes strength essentially. So that was one of the driving factors behind it. Then we gave it a name, called it Fritz, and then we said, yep, that's what we're going to do. All right, now let's do it. So we ended up buying an STL model. An STL model is not really ideal to machine, just depending on how those triangles are. I mean, you could have essentially seen a whole bunch of triangles on the part, right? And we didn't want that. So we took that STL model and we essentially constructed surfaces over the whole model. That probably was the biggest challenge in the whole project. Essentially, what I ended up doing is I just placed a whole bunch of lines on the STL. Then out of those lines, I created surfaces, and then you start trimming together all those surfaces. And I mean, I think overall, just to define the body, I think it's about 1,000 surfaces that have to be constructed.
Jeez.
And it's a pretty interesting process, but you really start understanding how surfaces are built. What do you need in surfaces? What do those individual UV lines need to look like? And then you can kind of see an output of it too. And then being able to understand the whole trimming that goes into that surface. Because for most people, you look at your part, well, it's just a 3D geometry on your screen, but there's so much more behind it. And I think being able to understand that and being able to manipulate it, then gives you a lot of tools that are very helpful if once you start applying them in real life. So once we had the model generated, and we didn't even have it completely generated, so I actually started roughing the block with part of the STL. So it's kind of this back and forth process of, I'm programming now, running the part on the machine, and I'm going to go back and I'm going to start getting these last couple of surfaces built around the face area or this area. And then I ended up, going importing and importing newer revisions of the model, and that was also pretty interesting. one of the things that you can see if you look at the front 2 feet, for example, I never understood why it took so long to calculate, but I forgot to delete um, certain surfaces. So there were two surfaces of the hoof of the bull, and you can kind of see too on the outcome of it. It's like a weird pattern on that versus on the back. Those tool paths calculate it really fast, and it looks really good. But that whole process of you got to get going on machining because you're running out of time. IMTS is just around the corner, but you're still not 100% done with the model. That was fun as well.
How did you do the
The
tail
logist,
with it being free floating like that?
yeah. So what I did there is essentially I drew I think it was like a 10 millimeter thick. It's just like a wall, and I machined all the way around that right to the end, and then at the end I started working away from the front of the tail, so right where it kind of curves up there, um, just start peeling away in there. And then once you had a certain amount of length, I went in there and I finished underneath. And then, you cut back a little more and then you finish again underneath and until you have the entire tail cleared out pretty much. So that essentially was just like an extruded solid underneath it where I said through the whole roughing process and the whole kind of right there till the end where I said, don't cut this area.
Okay. And then I had a question. What was the total cycle time for that?
I believe that was 50 hours.
Wow.
That's impressive.
But I mean, it started out as I think it was 1,024 pounds or so.
Whoa. I
I
didn't realize it was
remembered in
that heavy.
kilogram. That's the block of aluminum. So it was a 500 kilogram block of aluminum, and then we whittled it down to 100 kilograms.
Jeez.
It was a lot of gyps.
How long did that
And
take
one
you
of
to
the things
program?
I want to say, over including the modeling, I want to say it was about a 4 to 3 month time period.
Wow.
But that being said, too, is for us to do these demos, it's not like you sit there all 8 hours a day or 5 days a week doing this, because it's still you still have your daily business, right? You still gotta get all the other stuff. So it might be an email coming in, say, hey, we need a time study on this, we need a feasibility study on that. You do that, and then the bull was just one project. There was a lot of other projects that happened too. And so it's not just a dedicated 4 month period. It's more of a 4 month period where you took time to do that.
Of course.
Yeah. So what's going to happen with the IMTS demos that you had for this year? Because Jake was
Well,
saying that maybe he helped you out with those, or there was a collaboration there.
yeah. So those demos are actually being worked on yet. I mean, yes, IMTS didn't happen this year, so it kind of pushed the time frame of how soon we had to get these done a little past, but we're still actively working on that. And hopefully by the end of the year, we'll be ready to show that.
Awesome.
Unfortunately,
That's
I'm not
exciting.
going to say what it is yet, though.
No worries. We'll all be waiting for it for sure, though. That'll be great. So, kind of jumping back into your machines, Obsidian Tools asked, what are the differences between high precision machines like the Hermle and an ultra high precision like the Kern, and also split 141s? Kind of tail ending that was what tech makes your tier of 5-axis so much more accurate and repeatable than like a lower tier 5-axis?
Yeah. Well, tackle those in two different things, I would say, is probably the best thing. I don't think you can really compare a Kern to our machine. They're little different animals. They serve different markets. Kern is a very high accurate machine. But if you look at it, most of their sizes, so they have, I think, 4 different models with the micro and the pyramid. So I think there's like 3 different micro models and there's one pyramid. And if you look at those, all with the exception of the pyramid, have a travel that's comparable to our C12. And our C12 is going to be our smallest machine. If you look at the total capacity of those tables, they have I think it's a 50 kilogram capacity that they have on the table. We can put 120 or 150 kilograms on a C12. So it is a little bit different of an animal. I mean, I'm not 100% versed on their product, but I believe they have a lot of high RPM spindles. So I believe usually between the 30 and 40,000s, right? And their interface, it's I believe on HSK 40. We have a HSK 63 interface on there. So yes, it's very accurate, but it's really tailored towards that really smaller parts that need that high accuracy. One of the ways to look at it is, can you put a 42 millimeter drill in there and drill some 4140 heat treat? I can go out there right now, and I know I can do that on any of our machines, and I'm not even breaking a sweat. I don't think you're going to do that on an HSK 40 machine. So they're kind of tailored towards different avenues, right? Then the other thing is I think a lot of times you're looking at it, and you're looking at numbers, and what do those numbers really mean? So, and current is really, really accurate. But I would say, for what we're doing is, we're pretty darn accurate as well. And I don't think that, if you look at it, it's that far away. I mean, we're all talking about microns here. Current is going to be talking probably 2 to 5 microns. We might be talking, 8, 10, something like that. Depending on what standard you use. And when you're comparing all of these, that's one of the most important things is, how do you define accuracy? A lot of the times people are saying, well, your positioning tolerance is way larger than a different machine. Well, the way that those numbers are reported might be to the JIS standard. Well, we report numbers to the VDI standard. And for those standards then is, well, how do you measure the positioning accuracy? Do you travel forwards and backwards, and then do you evaluate, or do you just travel to one point and then travel to one point and evaluate? And so all those numbers, you really have to compare apples to apples. The one thing is too, a Kern, you'll be able to machine a mirror finish, and that thing's not going to break a sweat. It is an ultra high accurate machine. But again, can I make accurate large parts that weigh several hundred kilograms? So I would say those are, that's where you start getting into the differences. I mean, the other thing that you can't neglect is, how are they driving their machines? So how are they set up? It's a completely different concept, and that's why I don't like to say, I wouldn't want to compare a Hermle to a Kern in that sense.
Yeah, that totally makes sense. They're different, completely different machines. Yeah. So then, what about what makes your machines so much more accurate than, say, like a Haas UMC or something like that? Like, what does Hermle do in your design or in your software integration that makes it? I mean, 8 microns is incredibly high accurate still, especially volumetrically or anything like that. So, what makes your machine so accurate, for such large payloads and things like that?
Yeah. So what I would say is, when you start at the base of things, right? It is pretty much the whole machine is, with the exception of the gantry and whatnot, and smaller components, but the bed itself, where the trunnion is housed, that is one casting. On the smaller machines, that's a mineral casting. On the larger machines, the C52 and C62, that's a cast iron casting. And it really starts there. Your next step then is geometry. So I always talk about geometry, but that's how perpendicular and how planar, and how is that whole system, how good is that? The better that is, the better your result is going to be. Because you can have one mechanical side, and then you have a Heidenhain control. Yes, we do some stuff on the Heidenhain control that's unique to Hermle, but generally speaking, I put a Heidenhain control on any machine, right? And it has certain functions to do, for example, tilted machining. Well, the way to look at tilted machining is it's essentially a trig function. I know where the center of my rotaries lie in relationship to my machine coordinate system, and then I can trig out. Well, in order to be able to trig out, you kind of have to rely that everything is perpendicular and everything is planar where it needs to be. But if it's now at an angle, or if it's skewed a little bit, once I start tilting, it's no longer the right calculation, if you will. So that's why I say geometry is very, very important. And that's, where we're looking at, we do all this stuff in-house. And there's several checks that it goes through, and has to pass before it becomes a machine, essentially. But that's kind of the foundation of it. The other thing is Hermle spends a lot of time, I would say, on developing these. So it's not like every year you got this new model coming out. It's more like you got these small changes coming out, because we want to think through these items and kind of get it optimized to where we think they need to be. In the C series, so that's our current machine series that we have. It's been around for over 20 years now. And we just said, this is really the ideal kinematics. This is really how we think that a 5E axis needs to be built, and we'll build on top of that foundation.
Yeah, that makes sense. So Vidcock asked 5-axis machining center or 3-axis with a 5-axis rotary. When would you prefer one or over the other? So it sounds like you guys are, pretty sure that your trunnion design is the right way to go. I guess.
Why? I mean, they're two different animals, right? So you have a 5-axis milling machine, and now let's just, if you were to say, okay, let's just look at all 5-axis milling machines, dedicated design machines for that purpose. And then you have a 3-axis machine, and you throw a table on it. Well, that's just it. Is you just took a 3-axis machine and you threw a table on it that can now tilt. So, I think there's a lot of restrictions in it. And if I wanted to look at 5-axis, then I would be looking at a purposely designed 5-axis machine. I don't know how to answer, which one would be better in what scenario. I guess the only time I would say, I would want to go with the rotary setup on top of a table is if I had a need for a 3-axis machine, and then every now and then I had a need to be able to manipulate something in space. But if I needed a 5-axis machine, I would never look at a 3-axis with the rotary table. I would always go towards a system that was purposely designed for it. A large part of that kind of goes back to what I said earlier, where we talked about the heights and whatnot, and the offsets of something. So if we look at our machine, once I start tilting, where that trunnion is in space is really ideal for me to get to most areas of it. So once I start tilting my part and it's really long, I want to have that long Y travel. I don't really need a lot of X travel in our case, but I need a lot of Y travel. And if you just throw a rotary on your machine there, can it really be so purposely built that it would satisfy all those requirements? And then another thing, I've never personally worked with. I see it a lot at customers, but those units are pretty tall. And I understand 3-axis machines, you have a lot of C-axis travel, but I can imagine that is where you then see max tool lengths becoming a real big issue.
Yeah, totally. I think that answers the question perfectly.
Yeah. And then moving on to some automation questions from Obsidian Tools. He asks, do most people with automation run their programs the first time at the machine, or is it common to trust the simulation to let it run unattended at the start?
I would say that there's a healthy mix of that. It really depends on the customer and their parts, and then what system do they have in place? I can tell you if you have a good system in place, you really understand that whole process, you can throw that program in and you can say NC start, and then the machine will do exactly what you're telling it to do. You can rely on that the machine is going to do what you're telling it to do. But if you have a bad system in place that doesn't allow for that, then you're looking at collisions. And I think it's more or less a confidence level of, am I at that point of where I can just throw that in there? And that's where you start getting into, an area of, what would be important when you're looking at unattended machining. So for me, what's important when you're looking at unattended machining is really how is your post processor set up? Can you rely that every time you're getting that same output? Or is it when you have a certain combination or certain constellation of operations and settings that it then does something different? I kind of want that post processor to always spit out my code in a certain manner with certain, let's call them retract and safety moves. My work holding. So you want to have a certain system where your work holding is, you put it on there and you can rely that it is there where you had it set in your CAM system. It's not just a matter of, all right, I'm going to put a vice on my machine and then I'm going to run my program, right? A good example there too is does my virtual world match my actual world? And when you look at a vice, well, that vice could be at a 1 degree angle. Might not be a lot because you can simply just skew the C-axis and then it's straight. But now your computer, you're not going to put that vice at a 1 degree angle, right? When you make your assembly of your pallet, your vice, your part, you're going to have those nice and straight lined up. So now when you do your simulation, you're going to simulate it to that. Well, what happens with that 1 degree in real world when that table is tilted at that all the way out at this end? That's where you start running into issues there. Your tool libraries, you want to have a system of, how do I define my tools? When the tool gets assembled, is it always going to be what I actually simulated? And I think once you start putting all these things together and you have a good system in place, yeah, definitely. You can go out there, you can load everything up, and you're going to press NC start. Because at that point, when you have an automated system, you don't want to use it as a machine that just sits there and you're running a part for hours. And then you're like, okay, I think I got everything, and now I'm going to let it run overnight. I think a lot of times you need to get to that point and then let it just do its thing and trust in your system.
Awesome. Yeah. And then he also asked, what are key points people miss when they want to run parts unattended? So like what pitfalls do you see when customers approach you, for an automated solution? What are their misconceptions or what are they missing?
I think that kind of reflects back on the past is, for example, your post processor, it has to be set up for automation. If you're standing in front of a machine and running it and you have your hand on a potentiometer, you can catch things. But for me, it's more important than to, after certain operations come up, go over, then tilt my table and then come back down and then continue machining. A lot of people might say, well, that's really inefficient and it takes a couple of seconds out. But, I can rely on that process. And you have to have that kind of you have to have a concrete post that does the same thing every time and you can rely on. The same thing with your tooling. You can't go in there and say, you know what, I got my tool library and I just need a millimeter more stick out on this tool. And then you pull it out a millimeter, or you push it in, or whatever it may be. And then you have it in your system while you're running it. The computer thinks it's a 50 millimeter stick out. It's going to calculate everything to it. It's going to collision check to everything to it. And, those are the things that you then have to pay attention to. And once you don't pay attention to that, I think that's where people have issues when it comes to automation, because, then collisions start happening. The other big thing I would say is plan ahead with what do you want in your process? So don't don't start out throwing programs at your automation until you have an understanding. Okay, do I want to check for tool wear? Do I want to check for tool breakage? What do I want to have happen at what point in time? So you can put all the information already into your post. If you do a lot of drilling, well, do you want to use the automatic breakage function, or do you want to write your own routine? And when it gets to automation, I would say definitely write your own routine, because the automatic breakage is just going to say, well, tool's broken. Well, what do you do now? Do you, you know, do you continue on? Do you not continue on? If you write your own routines at that point, you can make those determinations. And understanding what you want your process to look like is key. And I think that's where a lot of people are like, well, I got this machine sitting on the floor, I need to get going. And you start heading a direction, but you might kind of back yourself into a corner. And in a year from now, you're like, oh, I really would need this. I really would need this. And then, a lot of customers do approach us with that. And they're like, I need this, I need this, and I need this. Well, we need to change this in your post. We need to do this. Oh, I don't want to do that because my whole system's already set up for that. A lot of things, what we see is, so both the Heidenhain and Siemens allow for, when you're calling up your tool, to either use a name or a number. So a lot of people, they'll start out using numbers. So they'll call up tool 1, they'll call up tool 2, they'll call up tool 3. Well, when you get into automation, you want to be able to use sister tools, because potentially you have a lot of unattended runtime, but you need multiple tools. So if you go by the number convention, well, what number replaces that tool? Versus if you go with the naming convention, the way the system happens, it starts searching for the tool at the top of the list, and it searches through. And all right, I found my 12 millimeter end mill, 124 XYZ. Can I use it? Yes. Okay, I'm going to get that into the spindle. Now that's run for 500 hours, puts it back into the magazine. And then when that tool gets called up again, it's going to hit that tool in the list and say, hey, I found my tool, but I can't use it because it's locked out through time. And then it's going to search or continue searching through the list until it finds another tool with that name, without you having to go in there and say, well, tool 100 is replaced by 105.
Gotcha. That's a really nice option actually on those controls.
But what a lot of people have done is, they've set up their entire tool libraries based on numbers. So it's one of those things that you definitely want to consider before you invest, potentially years worth of time in setting up a tool library.
Yeah. Well, I think, like you said, a lot of people come from a FANUC-based background where you don't really have an option. So it makes sense that people would start down that path and then realize their error.
Yep. No, definitely. That's understandable. So, but one of the things too is, what we try to at least do is we try to talk to the customer, and, when we can see, all right, they're heading an avenue, is, at least put that information out there so they can make the decisions that they need.
Totally. So I guess we can wrap up with some more fun questions that Jake had.
I have to ask about this one. He mentioned, do you guys have a badass coffee maker?
Yeah, I think he was thinking it has a retinal scanner to see whether you have red eyes and need like a extra strong dose. But it's essentially this coffee maker that has a touch screen, and you can pick coffee. Then you can pick how strong you want the coffee, and then it grinds up the the beans and mixes up your coffee. And you can select if you want a cappuccino, this or that. So yes, we still do have that, but we actually moved that coffee machine into our new break room, and it's no longer available for customers.
Oh, he's
But
going to
we do have a replacement coffee machine, but it's not as fancy. So it's one of those, where you have a cup, you can select which type of coffee you want, and that's what we got set up right now.
So you said new break room. So how is the expansion project at Hermle going? Hermle USA going?
Essentially, we are done with the expansion at this point. We're still moving into the showroom right now. Still trying to get everything set up the way we want it, but the expansion was completed a couple months ago. So we've added a significant amount of warehouse space. The showroom slash warehouse, or I should say the former showroom slash warehouse space, has now become completely dedicated to showroom. It was completely remodeled. New paint, new electrical system, new air system, to make it as flexible as we can. And then, our warehouse portion now just is going to allow us to, process things quite a bit faster, as well as store more parts. I mean, one of the things that you look at when, you're machine tool builder is, well, I have to have X amount of parts available. And every year when you sell more machines, well, then you also need more inventory and spare parts in order to be able to say, hey, we have these parts in stock, and essentially we can ship them out next day to you, and you'll have them, and not wait for a shipment from Germany.
Awesome. Yeah, that kind of support is really amazing. So he also asked, will you or Gunther be the first to fly on the private jet?
Yeah, well, that's definitely up to Ryan and Jacob, who they want to invite first on the plane. I mean, I definitely want to fly first, so I can finally sit in a luxury seat and not be behind the curtain. But I guess that's up to them too.
And then his last two were, who at Perryman was the best with a shotgun, and when can he come back to visit?
All right. Well, I'm not going to go on who was the best at a shotgun, but when I was there, um, one of the managers invited us to go out and do shotgun shooting. So myself, the guys from Perryman, as well as the gentleman from Autodesk that was there for developing the post, we went out and did a little bit of trap shooting. It was a great time.
That's awesome.
And essentially, I mean, currently, I mean, we can accept customers, and somebody can come here if they want to visit, take a look at what we have standing in our showroom, and take a look at our product at any time, really. Best thing is if you give us a little bit of heads up, because then we can also make sure that you have somebody with you, and we can spend a little bit of time with you on certain things that you might want to see. But anytime, Jacob can come back.
Awesome. Well, that takes care of our questions. Is there anything you want to plug? Do you guys have any webinars or, most events are canceled at this point, but is there anything that people should look forward to coming from Hermle?
Yeah, so with the showroom, I would expect this to be ready within the next 4 weeks. At that point, we'll start our trainings again. So it is laid out. So in the past, we've had trainings every month, and unfortunately, due to the construction and also partially due to COVID and how all that got delayed a little bit, we had a break here for some time, and we'll start that back up probably around November-ish.
Awesome.
So coming soon.
Yeah. Well, thank you so much for coming on the show. We really appreciate it. I've definitely learned a lot that I didn't know.
Yeah, same here. Thank you
Thanks
so much.
for having me.
All right, guys, we will
Thanks
see
for having
you
me.
in another week with another episode with Dylan and I.